All right, it's recording. Okay, so the first thing we need to work on is the heart rate.
Okay.
Go ahead and tell me the heart rate.
Okay, so heart rate. We're gonna go 1. Okay, you want me to do it with those? I don't care.
1, 2, 3.
So that's 5 millimeters each. So that's 15 millimeters. We'll say 15.2. Well, we'll say 15.
But that's
We'll say 16. We'll say 16.
I think it's 18 because
Wait,
this one is here, and this one I have like at least 2, and so that's 2 and 1. That's 18.
Okay, yeah, so 18. So 25 divided by 18 equals times 60 equals about 83 beats per minute.
Excellent. So we're doing fine. How was our, oh, forgot to write here. How's our rhythm?
Oh, go down again. It looked pretty consistent, pretty sinusy.
The word is regular. I told you many times. Regular. Exactly. So we have a sinus rhythm because we do see a P wave. So sinus rhythm.
Oh yeah, each QRS does have a P wave. I didn't notice that.
That is regular. Excellent. How's our PR interval?
PR interval. We're looking at the PR interval would be
from here
1
to here.
Yeah. So maybe 1, 2, 3, 4. 4 times 0.04 is 0.16, so that's good.
Yeah.
Normal is from 0.12 to 0.2.
Yeah. I wrote down the QTC to practice. So we do the QT in seconds divided by the R to R interval in seconds squared with the square root.
Okay.
And so let's work on
QT first.
This one, QT.
Okay. So we're looking at 1.
This is 0.2 seconds.
Yeah. Hold on.
Yeah.
0.2 plus 1, 2, 3.
I would go with 3, 2.
Yeah. So 0.2 plus 0.09. No, plus 0.12.
So 0.04, 0.08, 0.12.
Right. So 0.32.
No. Yes, correct.
Yes.
So 0.32, and now we do the P wave.
No, R to R. Right?
Sorry, the R to R.
So seconds. 1, 2. So we're looking at 1, 2. Wait, what did you write down here?
0.2 because we have in doing seconds.
2, 3.
So this 2 is 0.4.
Right, and then there's another one. So 0.6.
0.604.
0.64. Yeah, 0.64. Yeah. And 0.64, let's see. 0.64 square root of 0.64 equals 0.8. And then 0.32 divided. So 0.4 is the answer.
Do you see how important this is?
Yes.
Because this gave us a short QR, short QT. just by looking at it. But when we correct it with the QRS complex, we corrected it, and that's the actual one. So this is actually
what is the normal range on that?
0.36 to 0.44 seconds.
Okay.
Sometimes I think ACG cardiologists do use MS, milliseconds, but that just would be 360 to 440 milliseconds.
Right.
Okay. So we have a rhythm, right, and PR. All right, show me the mean electrical axis.
Show me the money. Show me the mean electrical axis.
For that, which leads are you going to use for this guy?
1 and AVF.
Exactly. 1.
But I can't see, remember?
F. Here's our 1,
so
and where's our AVF? Yeah.
1 is positive and AVF is negative,
and
which is what you would expect. That gives us quadrant 4.
Okay. What is AVF?
AVF is negative.
Why would that give you what were you expecting?
Why would that give you what I was expecting?
AVF should have a positive deflection if it's receiving the information.
I'm sorry. Yes. So quadrant 1.
There you go.
Yes,
all right,
you're right.
What should you be looking for in this quadrant?
Hemi blocks.
Okay, what type? Think about its location.
Yes. Wait, don't tell me. Anterior. Okay, so it's anterior and posterior. Anterior descending and posterior descending?
Okay, so it's just left anterior hemiblock.
Oh, just left anterior hemiblock?
Right, you don't mention descending or ascending. That has to do with an artery.
Okay.
You just mentioned its location, left anterior hemiblock. The other one is left posterior hemiblock. That's why you'll see it on this side. And that is a lateral view. And when you see a mistake there, it will reflect by having here. Okay? So that's the difference.
Okay.
Left anterior hemiblock. What do you look for in a left anterior hemiblock?
Oh, this I do not remember one bit.
Lead 1 being very positive. And AVL being also very positive. Why? Because this portion, oh my goodness, I'm sorry. This portion right here, it's not receiving the recording, okay? That's why you do see a negative sign. It's going away from it. It was going altered. Why? Because this part is not working. This does work. So what you're going to see is you're going to see from this side, which have the 1 and AVL receiving that information. And so later they will repolarize this way. And because it's going in an altered way, you get a negative deflection on the AVF. And also you're going to see it on the 2. And you might see it on the 3 as well. All right, so negative on AVF, 2 and 3. A lot of positive deflection on 1 and AVL, because imagine you have a highway that goes like this. What happens if this is stuck? Where are all the people going to go? To the other one, right? And so that's exactly what's going on here. You get more activity being recorded on this other one, okay? Because this is supposed to bifurcate in the middle. And as it bifurcates, If it's blocked, then you won't get more signal going this way. That's why you go from the other way. And there's more. It's more prominent. So what do we expect to see? A more prominent, look at that. It's huge. Where's our AVL? Huge. Where's our AVF? Negative. 3, negative. 2, negative. Does that make sense? So this is I think this is one of the easiest ones to locate for. All right, where are our chest leads? What do we see on our chest leads?
Oh, chest leads. We have number 1 is biphasic. Everything else is positive. 6 is positive.
Sorry, we forgot something very important. Sorry, before we do this, I forgot about our QRS. Let's look at our QRS because I'm looking at it and they don't look so good. What is our here to here? What's our QRS complex? How wide is it?
You know, I think maybe it's a little widened.
Hang on. Take a look at this one. This one's nicer to look for. Easier to see.
Yeah, I would say that it's widened.
Give me a number, man.
So 1, 2, 3.
It's definitely 3, right?
Yeah.
How many seconds are those?
3. It's 0.12 seconds.
And what is our QRS complex normally supposed to be? Less than how much?
Less than 0.12?
Less than 0.1.
Oh, less than 0.1. Okay, QRS less than 0.1.
So
this is definitely wide, right?
Yeah. So we have a broad QRS.
Yes.
A lot of things can explain a broad QRS. We do see it being consistent. All right, throughout the whole thing. So my question is now, do you see anything odd in the chest leads? Let's start with V1 to V3.
Okay, do I see anything consistent?
No, anything abnormal.
Oh, V1, V2, V3, because they're facing anterior, we expect them to be positive.
Right.
So that's good.
I don't like the fact that I'm looking at a biphasic.
Yes, that is biphasic.
Right on my lead V1. This should be normally located on the V3 and V4. So that's something that brings my attention. Now let's look at V4 and V5 and V6.
Do you see anything? Positive, V5 is positive. V6 is positive. I mean, well, V6 is positive, but I would say that it's also kind of biphasic.
Right.
Do I see anything? Well, they're all broad. Oh, but V5 has a weird little spike on it.
Yes. Do you see anything wrong on V6?
No. Well, yeah, I mean, I guess V6 has that little, does it have a delta wave? No, right?
Yes, sir. Yes,
Oh,
a delta
V6
wave.
so is V5 a delta wave too?
I think so. Not up here. but the delta wave occurs before the R wave. But this is more prominent right here. So if we have a delta wave that it's observed on the V6, if we have our beautiful heart here, divided like this, where is it actually the QR? Where is our Wolff Parkinson White syndrome occurring?
Where is it? What do you mean?
So Wolff Parkinson White syndrome refers to having an accessory pathway that if you have your road here, normally like this, that has to go through here, what you're actually having on a Wolff Parkinson White syndrome is they're saying, screw that, I'm taking this shortcut, or I'm taking this shortcut. So they do not go through the normal pathway. They're using an accessory pathway. So my question is, where in the heart is the accessory pathway?
Okay, so it's
if you know your
so
chest
it's
leads,
going up. Yes. So okay, wait, hold on. So it's going up, which means that it's the most common one, which means that it's on the left.
What do you mean by it's going up?
Like the delta wave is like it's going it's convex, not concave, is what I remember. No, or not convex versus concave. It's got like an upward trend versus like a downward one. That's kind of what I remember from that. And I know that if that's the case, then it's the most common one, and that's on the left-hand side of the card.
Can I ask you a question?
Yes.
What do you call this spike? I mean, I know it's a QRS, but let me just ask you, if this is isoelectric, what does it mean when it goes up? How do you call it?
When V6 goes up, when it's got a positive.
What do you call this when it goes up? What's the proper term?
It's got a positive inflection.
Inflection?
Yeah.
Deflection.
A positive deflection?
Yes. You need to start practicing using those terms. Whoops. These terms, again, remember I told you, if you know your terms, you know what you're saying. If you know what you're saying, people will take you seriously. Especially reading ECGs. Like you said it before, it's not something you need, but it's a huge plus.
Right.
So exactly, your location would be right here. Something's happening on the left side. Okay?
Mm-hmm.
Excellent. So let's look. I don't think, honestly, that was tough because, look, the delta wave is right there. Our P wave was normal. The PR interval, we found it normal. The QT, we found it to be, well, we did 0.4, but 0.37 still inside. Our QRS complex, we found it to be broad. One of the characteristics of delta wave is to be broad, having a broad QRS, right? Which makes sense because an accessory pathway is also occurring at the same time. And do I see anything else? Oh yeah, we saw the left anterior hemiblock because we see the one in AVL having an upward deflection. Our T wave is good. We haven't done J point. And these are the two things we found. The V1 has a greater amplitude. Accessory pathway is on left side. Where's our V? Oh yeah, it's a bit high, but we also see the delta wave. I saw it here more. Excellent. Excellent work. Any questions, Arturo?
No. Wait,